sound.
I'ma get it, you know I be on the way. Yeah. You know I be on the way. Man on a mission, I'ma get it, you know I be on the way. Yeah, man, we coming for the bags. If they said I couldn't have I got a vision for the things you ain't believe. And here's the motto, hard work is over everything. Rolling in and doing that work. Check priorities, doing that first. Checks big, sure that hurts, but it's checkmate. We ain't selling short, know the work. Ain't nowhere to hide. You ain't gotta see me come and keep me on your mind. Cause I be on the way. Yeah. I'm on the way. On the way. Yeah. I'm on the way. I'm on the way. I'm on the way.
All right. Good morning and welcome, everyone. As Alexis just said, my name is Nnanna. I'm a graphics engineer at Unity, and for the next 17 to 20 minutes, I'll be talking to you about building for PlayStation VR2 with the Universal Render Pipeline. Now, before we get started, this is my first time at GDC, so do y'all mind if I get a selfie? If I could try. Is that okay? All right, thank you. Let's see. All right. Everyone say Unity. Oh, yeah, come on in. Okay. So yeah, the PlayStation VR2 was launched a few weeks ago. Using the power of the PS5, the next-gen PS VR2 targets 4K resolutions at refresh rates of 90 to 120 hertz. It also comes with a bunch of new graphics features that can help you build even more stunning titles. In this talk, I'll discuss some of these features and how Unity's Universal Render Pipeline supports them. This session will primarily be focused around graphics and performance. Now, let's start at a lower interface level with NGGC, which stands for Next Generation Graphics Context. NGGC is a new rendering backend built for the PlayStation 5 to leverage all of its capabilities and architecture. NGGC is required to unlock PSVR2 development with Unity, but is also available to regular PS5 titles on all of Unity's rendering pipelines. This is from 2022.2 onwards, and also in the latest version of the 2021 LTS. Now, some advantages to expect from NGGC are that the high-resolution render textures required to achieve 4K on the PSVR2 can benefit from improved GPU bandwidth. This is because of NGGC's implementation of the PS5's runtime texture compression. Also building on the PS5's unique software architecture, NGGC is able to deliver faster command buffer generation and draw call submissions, leading to faster overall CPU performance. It also achieves fewer GPU context roles and more efficient resource synchronization as a result of a simpler, leaner design compared to its predecessor. Overall, it's more efficient on both GPU and CPU, and best of all, it does not require any modifications to your game code or assets. So how does this all translate in numbers? Using the Unity spaceship demo, running at 4K, we can see the new API is able to achieve 14% performance gain on the GPU and 32% improvement on CPU main thread. Memory usage is also reduced by about 30 megabytes. I'll reiterate that NGGC is available to all PS5 titles on all of Unity's render pipelines, but is prerequisite to developing for PSVR2 with Unity. Let's have a closer look at some specific features supported by Unity on the PSVR2. If you're familiar with VR development, you know how single pass techniques can dramatically reduce CPU usage by rendering for both eyes at the same time. For instance, frustum culling and command buffer generation can be done only once instead of twice. Unity gives you the ability to decide what you want to render on the TV for spectators watching the main player interact in VR. You could even decide to render a different view from an alternative camera and offer some kind of asymmetric gameplay experience, or a different user interface for local spectators. Another traditional optimization when doing VR rendering is to start the frame by drawing an occlusion mesh to the depth buffer. This is in order to avoid what is not visible outside of the headset. Unity provides default settings to allow you to set up the resolution of the connected device, and you're always free to take control and change those defaults to meet your performance needs. The PSVR2 can run at different frame rates. This is a versatile option that lets you decide what you want to give your players. You can also decide to run at 60 frames per second and reproject these frames to 120 FPS to get the best of both worlds. You can decide to make a game where VR is optional or where VR mode can be toggled on and off. As a developer, you have total control over the flow of your game. Now let's dig into some URP specifics, starting with this clip. Now this is from one of the scenes in a new template showcasing how different visual styles can be achieved using the universal render pipeline. This clip was captured on the PS5, running on the PSVR2 at 60 Hertz, reprojected to 120 Hertz. Now, massive thank you to Ryan Cassell, he's over there, who helped set up this scene to run on the PSVR2. And shout out to the team as well, who helped build this amazing demo and the other scenes involved. You can check out the other scenes at that point, at stand in this booth. As you can see, this is beautifully stylized. It's, the interiors are all built up from modular components, and the vegetation is all dynamically lit and procedurally animated. Further ahead in the video, there's this water fountain that flows into a stream that just stretches across the garden. Basically, it is quite typical of what you would find in a regular game scene or even a VR game. And this is running on the PSVR2. The Unity project for this will be available on the PlayStation Developer Portal as soon as possible. But note that you need to be a registered PlayStation developer in order to access this content. A lot of great features exist in URP to help you achieve your target performance and visual fidelity, some of which have been implemented to further empower PlayStation VR2 developers. Out of the box, Foveated Rendering and eye tracking are fully available to developers from 2022.2 onwards. These features combined can achieve great visuals at a fraction of the GPU cost. The next sections will explore these further. And we'll also look at performance comparisons and expected trade-offs between single-pass rendering and multi-pass rendering. First off, foveated rendering. This is a set of techniques that takes advantage of how human vision works by reducing the image quality around the peripheral vision and targeting the highest image quality at the central area of your eye's focus. Now, since your fovea, where you see most clearly, is relatively small when you compare that to the optics of the headset, this trade-off greatly improves GPU performance without any noticeable loss in quality. URP supports this and provides settings to adjust the scale of this foveation area in your projects. PS VR2's hardware can go a step further by using eye tracking in order to optimize the GPU even more. We project the eye gaze information into screen space, and we're able to render the highest pixel quality at the precise screen area where the player is looking. I'd repeat that foveated rendering and eye tracking are fully available in URP to developers with no additional effort. Now, let's look at some performance figures, specifically around single pass and multi-pass rendering, and how they can each benefit from foveated rendering and eye tracking. As previously mentioned, single pass techniques can dramatically reduce CPU usage by rendering for both eyes at the same time. It, however, needs to draw to a render target big enough to fit the view from both eyes. So GPU cost and bandwidth may invariably be affected by this. For this benchmark, we've used the garden scene, which you saw earlier, and all the timings from this are from how long it takes the GPU to process a frame using the same scene setup. With foveated rendering enabled during single pass, we're able to achieve over 30 frames per second compared to around 20 frames per second without it. I hope you can see it. I know it's a bit low, sorry about that, but hopefully you can see the numbers at the bottom. Now, going further by pairing eye tracking with foveated rendering, we start to achieve almost 70 frames per second, more than 3 times the original performance. Now, let's look at multipass. Unity's multipass rendering benefits the most from foveated rendering. This is because its implementation can take advantage of both foveated rendering and eye tracking in ways that single pass currently cannot. However, since it works by rendering for both eyes, it renders the scene twice, once per eye, its CPU cost can be considerably higher than single pass. And in this case, we can see that its GPU cost is also higher, starting off at about 19 frames per second, 3 milliseconds slower than its equivalent single pass technique. However, with foveated rendering, the frame rate more than doubles in performance, getting close to 50 frames per second and more than 7 milliseconds faster than its single pass equivalent. Now, this gap from the original widens even further, about 4 times of the original performance. That's about 80 frames per second and 2 milliseconds faster than its single pass equivalent. Now, your results may vary from scene to scene, but I hope this gives you an idea of the sort of improvements and gains you could get with these technologies. As part of the unified development process, PS VR2's workflow is fully integrated into Unity's toolsets. The Unity Frame Debugger, for example, can be attached to a live instance of your PSVR2 game, and you can inspect how a single pass or multi-pass frame has been composed. You can step through individual draw calls and view their associated render state and resources. The memory profiler can be used to capture snapshots of your running game. So you can dig into memory usage at specific points in your game and pinpoint assets that may need optimization. You can also compare snapshots to track how your game's memory usage has evolved over time. This is all from the Unity editor while running your game on the PSVR2, on the PS5. And finally, the Unity profiler helps you visualize detailed performance information about your game, including your own custom metrics, giving you insights into where optimizations would be most beneficial. Before I conclude, allow me to point out a few additional features and improvements that you may find useful. The Universal Render Pipeline now supports working with high dynamic range displays from 2023.1 on PC and consoles. And with 2023.2, we're looking to extend this support to XR devices and also make it available in the 2022.2 version. Shader variant pre-filtering. Now, this is a new feature available from the 2021 LTS onwards that massively improves build times, cutting as much as 90% of build times in some cases. It works by excluding a significant percentage of unused shader variants ahead of the shader stripping stage. Now, shader stripping can be a time-consuming process due to needing to enumerate a large number of shaders. But with pre-filtering, it now only enumerates a small subset of those shaders. And more improvements around this feature are still incoming. And finally, the Unity XR Interaction Toolkit. This is available on GitHub or as a Unity package. This is a useful framework to help you onboard and accelerate your VR development journey. It makes it really easy to transform an existing Unity scene into a VR-compatible scene. There's prefabs that make it seamless to add VR support to your scenes, so you don't have to worry about implementing stuff like hand tracking or a headset-tracked camera. And there's various kinds of VR interactions out of the box that can easily be set up for your target VR controllers across multiple platforms. All these and more are geared towards removing the technical hurdles so you can focus on what makes your game great. At Unity, we believe the world is a better place with more creators in it. I hope you're now as excited as I am about how Unity's Universal Render Pipeline can help both seasoned and aspiring PSVR2 developers to achieve their vision. We can't wait to see what you create. Thank you all for coming. If you have any questions, you can catch me around the booth. I'll be more than happy to chat. Thank you.